Hello everyone, my name is Sai. I work as a security engineer for Check Point, and today we will be talking about how you build a CI/CD pipeline to deliver a Lambda application, Lambda serverless application, and how we secure it with Check Point tools. Using Check Point's CloudGuard family of security tools to secure our cloud service provider accounts, whether it's AWS or Azure or Google Cloud. For this demo, we will be using AWS, and we will be particularly focusing on how the CloudGuard family of tools will help us secure serverless applications. Besides that, it also does help with security posture management, it does help with threat hunting, and does help with preventing and protecting web application and API attacks. Let's take a closer look at what kind of security protections are offered by the CloudGuard family for serverless workloads. The protection is primarily divided into two sections. It's code scanning and runtime protection. In code scanning, essentially the code of the application and the templates that are used to build the application are scanned, and it is the configuration of the deployment is assessed, the privileges of the role, IAM role is assessed, the code is assessed for dependency vulnerabilities, a form of software composition analysis. And on the runtime security part, the layer is wrapped around the Lambda function, and this helps with preventing and detecting OWASP style attacks. It helps with profiling the behavior of the application and then detecting anomalous behavior, and it helps with defining granular zero trust policies. Let's take a look at the pictorial representation of our CI/CD pipeline before we get into the actual hands-on. So moving from left to right, you notice that we use GitHub as our code repository. We are primarily using GitHub Actions on the initial part of our CI/CD pipeline for performing code scan. To just give you a brief on what GitHub Actions is, it is a hosted CI/CD service provided by GitHub. Essentially, you should be able to use GitHub Actions to perform your entire pipeline's tasks and deploy your applications, but we will be using it only for the former sections of this pipeline. Once the code is uploaded and GitHub Actions are run, a webhook trigger is launched to the code pipeline of our AWS account. Through this, the source code is pulled from GitHub, and this triggers the code pipeline flow in our AWS account. Right after sourcing the code, we immediately get into a build operation. We use code build here, AWS code build, and the primary task of AWS code build here is to convert the CloudFormation template to a template that has a Check Point runtime protection built into it, and then convert that template from a SAM template format to that of a standard CloudFormation template format. Not much else build work here. Once that is done and triggered, the code and the converted templates are stored in S3, and this triggers the CloudFormation application where we create a change set on a stack. A change set is essentially us aggregating all the changes that we would want to make in a particular CloudFormation stack, and we are then able to place a terminal of manual approval there, post of which we can execute the change set. This is essentially like the plan phase of your Terraform builds, if you will. And once we approve, this triggers the execute change set operation, and this then leads to the deployment of the serverless function, which is secured by Check Point runtime layer. And of course, the typical best practice of storing the API keys in API keys for CloudGuard Serverless is placed in Secrets Manager, and similarly the respective API keys for CloudGuard Serverless is placed in GitHub Secrets. Let's take a look at the code for the application that we have stored in GitHub. The index.js right here is the code for the application itself. It's quite a straightforward application. The intention of the application is to just display the time once the function is invoked. Let's also take a look at the adjoining artifacts. We have buildspec.yaml. The purpose of buildspec.yaml is to provide instructions to AWS code build during the build phase on what it is supposed to do. We'll have a brief run through on what some of these code mean. So as you can see, during the declaration phase, we are declaring an environment and we are pulling variables that are stored in AWS Secrets Manager, and we're declaring two variables, which is the CloudGuard ID and the CloudGuard key. So these are the API ID and key required for us to make calls to our CloudGuard serverless SaaS application to perform the required tasks. The ID and key is stored in AWS Secrets Manager. We are declaring that the runtime for this particular environment is Node.js because our application is built with Node.js. And during the build phase, we perform an array of commands. Skimming through it quickly, we initially install the necessary packages for CloudGuard Serverless. We install the plugin. We then declare a bucket where we would be eventually uploading the code of the application and the template on how it will be deployed, the CloudFormation template. This is the actual call to CloudGuard serverless application. We are calling the function self-protection aspect of it, the runtime protection, and we are essentially saying that here is the template for deploying that application. The template of the application template for deploying that application will be modified to add a layer that enables function self-protection from Check Point, and this throws an output template 1.yaml. And then finally we call in the AWS CloudFormation package API call, where the code itself is packaged into a zip file, and it is stored in the corresponding S3 bucket. The template itself, the output template of the previous command, is then modified to reflect the fact that the code is now stored in a different place, and it's renamed to output template.yaml. And as you can see, following artifacts are defined. The types are zip, and we have two YAML files that are considered the build artifacts. Let's take a look at the template itself. The definition of the template is very similar to that of a CloudFormation template. This is in fact a SAM template. To be specific, it is a subset of CloudFormation templates. The key difference is this line right here, which defines that it is a SAM template, not just a generic CloudFormation template. And the essence of SAM template is for us to be able to define serverless applications and their their relative infrastructures that are required to support them. Let's say API gateways in this example. So here we are essentially defining a serverless function called time function, the type of which is a serverless function. The properties we immediately describe of it are the handler, as in the function that is first invoked when the corresponding serverless function is called, the runtime of the serverless function, the location of the respective code of the serverless function, and the events that would be able to trigger that serverless function. Within that, we again define an event called MyTime API, which is actually the API for that particular application. It's an API gateway entity, and we also define the path and the method of that particular API call. And finally, let's take a look at the GitHub Actions code that we will be using. This code is essentially run on services hosted by GitHub themselves, and GitHub Actions in essence are a very deep and diverse set of community and GitHub maintained tools that would be good enough for you to run your entire CI/CD pipeline on it, but for the sake of this application you will only be using it for the code scan. So as you can see, we define the name of the application, and we are immediately talking about on what situations we will be calling this particular workflow. You would be calling it whenever there is a push to our repository, GitHub repository, or whenever there is a pull request, particularly to the master branch, or whenever we would need to manually trigger it. That's what workflow dispatch means. We are immediately defining a job, which is a set of tasks in a sense. We're defining the environment in which these jobs would be run. It would be run on a Ubuntu environment, and we start off with our tasks or steps, as you will, from here. I usually start off with the checkout step, where we would be pulling the code from the code repository from GitHub, and we will be placing it in the runtime environment that is created by GitHub. We will then be logging into AWS. So this particular action is required as a supporting action for the code scan. The CloudGuard ProAct code scan does require you to have programmatic access to AWS, the particular region, during the time in which the command is run. So we will be logging in for that primarily. Once we do log in, now we will be actually running our code scan. As you can see, I first will install the necessary packages, and then I will be immediately running the CloudGuard ProAct code scan. Once the code scan is done, whatever reports are generated from that will be uploaded to an S3 bucket, which I have created particularly for that purpose. S3 bucket proact scan report. Let's go ahead and create the code pipeline. So right here I'm at the AWS Codepipeline service. I'm creating a pipeline called time app pipeline. It will be creating a role corresponding to it, and it will be modifying it as based on its needs. We'll leave it as B. We will be sourcing our code from GitHub. We will be using GitHub version 2 to import to provide connection. So if your AWS account is not already connected to your GitHub account, you would need to click on connect now and proceed with that. I have already connected my AWS account to GitHub, to my GitHub repository in particular. So I select the corresponding repository, which is Lambda time app. I select the master branch. So as soon as the code is committed to or pushed to the master branch, the webhook will be triggered from GitHub to AWS Codepipeline, and that will begin the cogs from moving in AWS Codepipeline. Build provider, we will be using AWS Code Build. We'll go ahead and create a project just for this purpose. Time app code build 1. So we will be using a managed code build image. Ubuntu is a choice that we'll be making. We'll be doing standard runtime. We'll be using the 4.0 version of that, and we'll be creating a new service role for the purpose of this code build. Do note that we will have to edit this particular service role once it's been created to accommodate certain permissions, which we'll talk about later. We will be using the buildspec.yaml file that we saw before to instruct the code build run on what is supposed to be done during the run, and we will be logging. So we'll go ahead and create this code pipeline. Perfect. We'll move on to the next stage, and right now here we are at the deploy stage. We will skip the wizard right now. We will skip the deploy stage of the wizard, and we'll go ahead and cut to the part where we review and create the pipeline. I personally prefer doing this because our pipeline gets a bit more customized from here. We will be doing that as it goes on now. Let's stop execution. All right. Let's go ahead and edit our pipeline here. And let's start adding further stages. The next stage that we will be adding here is something I would call the create chain set stage. So here, as the name implies, we will be using CloudFormation. We will be taking the artifacts from the sourcing stage, and we will be creating a change set. I'll be calling the change set time app stack 1. And I'll be calling the change set time app CS. There seems to be a problem with the build artifacts reflecting. Oh, there you go. So let's go ahead and name this option again. Alright, we'll call this time app stack 1 change set time app CS. The template is present in the build artifacts, and as we saw in the code, it's called output template .yaml. Capabilities, we are supposed to mention IAM and auto expand. The role, we do need to provide the Lambda pipeline role. It is essentially the role that is required to perform the changes, creating the corresponding changes in the change set. And we'll go ahead and put a close to that. That's the create change set stage. Let's add another stage called manual approval, or we'll just call it approval. As the name suggests, the intention of this stage is to give a pause in the pipeline to accommodate a manual review and approval. So this is a stage where approval is solicited. You can put an SNS topic for an email to be sent out if required. I will in particular just put down the URL of the bucket that has the reports that were pulled during the initial scan. I'll be mentioning that here for the purpose of the reviewer. Then finally we'll add another stage called deploy, which is essentially deploying the change set. With the execute change set state, we'll be using AWS CloudFormation. Import artifacts would essentially require You go ahead and call execute change set. You can recall the name exactly, it was time app 1, and the change set is time app CS. That should be about it. And these should be the 5 stages. Let's go ahead and give it a close. We've gone ahead and built our pipeline here. There are minor tweaks that we are still supposed to do. Primarily, it's to do with the permissions during the build phase. If you can recall, during the build phase, we access secrets stored in secret manager, and we also access an S3 bucket to store the code once we have packaged it. So we have to go ahead and provide the necessary permission for the role that is used by our code build. We're using the time app code build 1, so let's go ahead. Time app code build 1. You can see it's failed. That's probably because of the permission error. Let's go ahead and edit the figure out environment. Okay, that's the service role that's associated with our build process. Let's go ahead and modify the permissions. As you can see, there is read and write permission, but it's only restricted to bucket names that are Codepipeline US East 1. That is meant to read the source code that is pulled in during the source phase. We will also need to provide access to one other bucket, that is our bucket where we will also be storing the packaged code. So we will be modifying that as well. We'll be adding another ARN here, particularly the ARN of app to artifact bucket. This is the bucket that we will use to store the code. We're essentially providing access to all the resources within that bucket. Let's also provide the ability to read and access our secrets stored in secret manager. Secret manager, list and read resources. You can manually list the resources here. I, however, will be going with all resources. We'll be reviewing and saving that. And now that the permission has been provided, let's go back to the code build phase. Go to the pipeline. initiated release. Alright, I believe the pipeline is now completely executed, and we do have the code finally deployed from timeout pipeline. Let's go ahead and check Lambda to see if it is deployed. There you go. Time up stack 1 time function deployed a minute ago, run a minute ago. Let's try to execute it. Let's try to figure out the API gateway that corresponds to that particular serverless function. And let's try to call it and see if we get an output. Time up stack 1. There you go. Time in India is 17:43. Let's now do one full trial run on what happens when you are making changes to your app and you're availing the entire pipeline from GitHub Actions all the way to Codepipeline and to the deployment in Lambda. So just as a simple outlier, let's create a new branch. I'll call this edit one branch. Let's go ahead and edit the index file. We'll make a small change. Now that we made a change, let's go ahead and review the code. We put in a hey, we made it sound a bit more polite. We'll go ahead and initiate a pull request. We'll try to merge it to the branch, to the master. I'll initiate a pull. And as you can see, there is a scan that is been initiated. To actually, for one, when we push the change to the branch, but we will be reviewing the scan that's happening for the push to the pull request to the master. As you can see, the code was initially checked out. We logged into AWS because that's required for the remainder of the workflow, and now we are initiating the code scan as part of this workflow, as part of this step, sorry. go, scanning has been initiated. And scanning is complete. Let me open that up again for your purview. Scanning was complete. For the time function, there is a bit of a permissive role. It's a low warning, so the pull request was not dropped. There was no issue with vulnerability dependency, credential usage, or any other sort of rule violation. The report of it has been generated, and I have subsequently uploaded the report to S3. I can access it if I want. This is where it's been uploaded to, and another post job artifacts. So the scan is run. I can now review the file if I want to, but I have a pull request right here that I would have to approve. Now if I were to approve this pull request, that's when you see the second half of the pipeline go into effect. Let's take a look at the code now, just to make sure that the request has been merged. We are in master right now. And as you can see, our edit stands in master. Hey, time in India is, so the reflect is the merge has worked. Let's go ahead and take a look at our pipeline. And see if it's been triggered. And as you can see, it is triggered. It's in the process. The source code was pulled, and now it's at build. As you can see, we are now at a stage of manual review. We can go ahead and decide to review. We'll take a look at the report that was generated. Today is the 14th of December. This is our report that was generated. Let's go ahead and open the object. As the initial review showed, everything is fine. The rule violation, vulnerability dependency, credential usage is fine. There is a slight issue with the permissive role. There is also a suggested fix on what kind of rule to use. It's not too much of a damper for me. I will go ahead and initiate or approve the roll of this code into production, and this will start the deployment. As you can see, the code has been executed. Let's go and check our website and see what it reflects the change now. Okay, the time in India is 17:59. There you go. Let's review our Lambda ones to showcase that we do have the checkpoint runtime protection as part of it. So this is our function right here. Let's get the latest alias. Let's check out the code. This is the code of our application, and as you can see, in layers we do have the CloudGuard FSP function self protection, which is the runtime protection layer woven around the code. And there you go.